Sweet. So then that means that the light, we can go and check out the light to see if the motion.
Oh yeah, let's go.
Yeah. So if we just walk in here. Oh,
look at that.
That was pretty nice, yeah.
It detected motion from that sensor and turned it down.
Yeah, so it detected the motion, and then it went back to the device or whatever, and then it toned that up.
That's awesome.
So now we're going to test to see how well it works when it's the vent is attached to the temperature sensor. So basically what this means is that our desired temperature is currently set higher than what the current temperature in the room is, so that means that the vent will be open. Yep. But with this hairdryer, we're going to simulate heat coming out of the vent and heating up the temperature sensor that's
Alright, so let's do it.
Wow.
Oh, look at that, it explodes. So that means if you put this in the freeze, then it should open itself, right?
Stick that thing in the freezer.
Alright, let's do it.
You can just leave it in there. It'll probably get colder faster.
Alright. So, let's see.
It's about to.
Oh, look at that, it opened.
Oh, wow, sweet.
That's perfect, awesome.
Alright, yeah.
Alright, so we can I heard that we could also view the usage data and all, like in a graphical representation. So let's just check it out.
Cool.
Oh, look at that, all this graph.
See. Let's see the temperature. Did it go down when we put it in the freezer?
Oh, look at that, it went down.
It did, yeah.
So this is LT, light temperature sensor. Blue one, blue is the temperature, it goes down.
Okay, sweet,
That's
yeah.
nice.
Alright. We're gonna log out and show how all the stuff stays. So.
Alright, so let's log out. Let's close the browser too. Oops. Home automation. Alright, so login, username, select house. It is level 1, right?
Yeah, I think so.
Oh, there it is. So it basically saves everything. Right. So if I hit that button, it will turn on that light, right?
I don't know, let's try it. Oh,
there
sweet,
it is.
yeah,
Awesome.
it turns on, sweet. So,
Perfect.
Yep. Alright, wow, this
so
is
look at that.
sweet.
Yep, it even shows all the temperature and light in this room.
That's pretty sweet. So yeah, now we can get more vents and more temperature sensors, and then we could put a vent in every single room, and then basically manage the zone on every single one. So it's like if we in this storage room, we wouldn't have to heat it very much.
And why would you hit all those guest room and all when there's no one around?
Exactly, and it's like with the motion sensor, you can look at the data to see when the motion is and when people are there, and then you can basically turn stuff on and off.
Yeah, exactly. And since it logs everything, you can pretty much like analyze this data and like do predictions and things like that in future. Right. So alright.
Alright, so do we want to go and do just a brief, let's kind of do an impromptu explanation of everything. We hope that you liked our little demo that we had, but there's quite a bit of different things that go on behind the scenes, so we're just going to kind of briefly go over just kind of everything that's happening. We'll kind of start with just the hardware. So basically, we have the light here, and when we were thinking about making it, we really wanted it not to use batteries. So this basically just kind of consists of an XB module, a transformer, a relay, transistor, and then a regulator, I think.
Yeah, and also we also wanted to make it like as easy as possible to set up. So what we did was we have this you can just plug this in any regular socket and plug in your light bulb, and there it is, Zigbee enabled light bulb. So do you want to open it and show what we have?
Well, I don't know, do you want to do that, or do you want to just do this stuff briefly?
Okay, it doesn't matter. We can just.
Okay, yeah, let's open it up quick.
Yeah, just show what we have. Why don't you come in? So what we have is we have a Zigbee relay and a transformer. Yep.
Cool. all that stuff fits in such a little area.
Yep. And it looks so professional.
Yeah.
Alright, so let's set this aside.
Yep. So then we have the vent. This vent has this little detachable little module, I guess you'd call it. And inside here, basically, we have the LED, we have 4 transistors, resistors, and then we have the XB module along with the batteries. So basically, we use 3 digital outputs, 1 for the LED and then 2 for controlling the motor, either opening or closing the vent. And as you can see from the video, our initial prototype was pretty bad, but we made it a lot better. Yeah. So then we have the motion sensor. Do you want to explain how that works real quick? Because just kind of briefly explain what's
so this is just a prototype motion sensor. What we have is this adapter for Zigbee. The only reason for using this was it was like easy to use, just plug and play. So we kind of use this adapter from adaptfruit.com, and we have this motion sensor. What it does is so as soon as it detects motion, it will send an input and an analog output, and output goes in this microcontroller, and then this microcontroller communicates with Zigbee whenever there is a motion. So basically, and Zigbee will transmit data to its coordinator every second. That's pretty much it. And we have used only 1 analog pin. That's pin number 2 or something. That's
and we've been having some problems with this motion sensor because this motion sensor isn't the greatest, but I'm sure we can find some better ones or whatever. You want to explain the registration process, because with the whole iDigi thing or whatever, and how that all works seamlessly with the website.
Yeah, sure. So basically, we wanted to make everything as simple as possible, as less few clicks as possible. So what we did was, when you register, you basically register we go to our website, and then you enter your username, password, and everything. And then when you create a new house, what we ask you is, we ask you to enter your gateway's MAC address. So once you get that MAC address, when you hit submit, what we do is we do HTTP post to iDigi server and create a new account on your username, and then what we provision the device into the iDigi server doing a HTTP post, and then device will automatically connect to the iDigi server. So that's how it kind of works. And then so when you hit that go green button, what it does is it generates a YML file dynamically and then uploads it into a device. Then what it does is it reboots the device and sends a command to a device saying, hey, run this dir.python file, and that's pretty much it. So it basically does everything behind the scene with just a single click.
Do you want to kind of explain the website just maybe a little more, with just the layout and stuff and whatever? I don't know. Is there anything else you want to say about the website?
Yeah, let's see. Drag and drop. What else?
How it auto updates in the database and stuff like that.
Okay.
Yeah, so we have the device using the CWM Exist presentation layer, and it just pushes up all the samples up to the iDigi platform every 5-10 seconds or something like that. And then we have one of our own scripts that basically does a pretty cool X query and just grabs all of the samples in just one file, parses it out, and then puts it into a MySQL database so we can locally query it as many times as we want, so we don't have to worry about the throttles.
And what our website does is every 10 seconds or 5 seconds it goes and locally queries those data from the database and updates all the sensors, GUI, without refreshing a page. And also, when we made our website, we wanted to make it as professional as possible, so we had a really nice design and Web 2.0 stuffs. We had glossy icons, round corners, and everything. So when we made the website, we wanted to make it really simple, easy to use, intuitive. So we had all these drag and drops. You could basically drag and drop sensors, drag and drop objects on your house, and create a layout of your house. Yep.
So explain the go green button. Did you explain the discover button? So the discover button, did you mention that at all or whatever?
Yeah, we talked about that at the beginning. Okay.
So then for the DIA, basically all these things is kind of interacting with the DIA through RCI and SCI mainly. But so with the DIA, we had to make 3 new drivers. We made the XB Lite, the XB Vent, and the XB Motion. And those 3 drivers, they're all new, but they're based off of the XB DIO. Right? Is that what it's called?
Yeah. Digital input output.
Yeah. And then
we also modified LTH.
Yeah, so we modified the LTH, the XB sensor driver. So and then we also added one method to the XB manager, which basically allows us to have these devices communicate, amongst each other, just from the X4.
So yeah, basically you could attach a motion sensor to a light. So you could attach an XP motion to a XP light. So whenever there's a motion, XP light driver would automatically turn on the light.
Yeah. So then with like the XP light driver, we just have like the two digital pins, the one for the LED and one for the light, and then we basically have a separate thread for both the XP sensor, the XP light, or the XP motion, and the XP sensor that basically manages dynamically whether or not it needs to like open and close, turn the light on and off, or open and close the vent. Yeah. So, and that can all be specified dynamically through the YML file. So in the YML file, we just have this extra little default, or this extra extended address that you can specify that's not required to associate these devices amongst each other. So, is there anything else? So then, some of our future work that we're thinking about doing, because this is really just the beginning. We spent a lot of time on the hardware, just kind of the basic framework or whatever.
And then we also did some research on like what could be possible. Like we basically had like two topics in our research. One was like using Zigbee modules and all. Is it possible to predict futures, like analyzing all this usage data and all. And other thing we did research on was, so okay, is it possible to automate home and save energy at the same time? So that is basically two research we did, and so that's kind of what we're working on right now. Some of the future works would be like predicting like events and all. So at this time, at this week, where will this man be in the house, or some things like that.
So, what else? Yeah, and then we'll use the fuzzy logic, basically take those predictions and then make decisions based off that. So since, we can go to, a person usually goes to work at about the same time, this system then could, decide to turn down the temperature throughout the house and stuff like that and know when to turn it back on.
Yeah, exactly. And then like you're heating the water when there's no one at the house. So why would you waste energy turning on the heat system when there's no one around? So in future what we could do is like, since we could predict all these events and all when people are in home and when people are not in home, we can somehow turn off the heaters when people are not in home and things like, and save energy. That's the basic whole idea about this project.
Yeah. Is that it? We hope that you enjoyed our demo and all the work that we've done, and we hope we have as much fun watching these videos as we have made have been making them.
Yeah.
They're kind of long, but I hope that you enjoy
watching it as we enjoy doing it.
Yeah. Right, cool.
Alright then, so bye-bye.
Go green.